Today we're going to talk about Powermasters, how to hook them up and what they're used for. The Lionel Powermasters are available in two different models. The earlier model would be, they're both actually in the same colored package. It's a gray package, looks just like a command base, but it says Lionel across the front. But it's important to note the difference between the two. The more modern version has a switch just to the left of the Molex connector, which allows you to select between 180 watt powerhouse and 135 watt powerhouse. The other Powermaster has no switch. The units without the switch are designed for use only with the 135 watt powerhouse. The difference between the two, as you can clearly see, the on-off switch for the 135 is on the face with the breaker down there, and the 180 watt has the on-off switch and this resettable circuit breaker on the top. The purpose of a Powermaster is basically a device to go between either your conventional transformer and the track, or your powerhouse and the track. What it does is it allows your wireless remote to communicate directly with the Powermaster to increase and decrease track voltage. By doing this, you're able to actually, by the switch on the side of the Powermaster, there's one that says conventional and the other position is command. Basically what that means is in the conventional mode, by using the red thumb wheel on the remote, as you turn the thumb wheel clockwise, you're able to increase your track voltage all the way up to 18 volts. As you turn it counterclockwise, you're able to decrease your voltage. Pressing the direction button will interrupt your track power to allow your conventional engines to cycle between forward, neutral, reverse, and neutral. The whistle button will generate the positive DC offset on the track to activate your whistle. Bell generates the negative DC offset on the track to turn the bell on. Pressing bell again will obviously turn the bell off. And this is on conventional locomotives when the switch is in the conventional position. By moving the switch to command, what you're doing is you're basically setting the Powermaster up to just turn track power on and turn track power off. When you turn that track power on, it's coming on at a full 18 volts. When you turn it off, it goes to 0 volts. The advantage to having the Powermasters in the equation is that you're able to use the remote to turn your track power on and off. This is completely separate from controlling the locomotives themselves. You're able to still control command control locomotives when there's 18 volts on the track and you're sending it digital signals through the halo over the rails. But you can also control the track power independent of the locomotives. So in the event of an emergency, perhaps a cornfield meet that's coming, you can hit the panic button on the cab 1. When you hit the panic button, the Powermaster shuts the power off to the track. Without a Powermaster in the equation, hitting the halt button would simply make the train stop. The other feature that the Powermaster offers you is circuit protection. Should you have a derailment on the track, the Powermaster has an internal circuit breaker that'll kick and immediately stop applying power to the track so that no damage occurs to the electronics on board the locomotives. We're going to go ahead and take a few minutes and talk about how to wire a Powermaster to your railroad. Before we start, I want to cover a couple of part numbers. First, the Powermaster. Those are sold under part number 12867. If you're using the Powermaster with a AC transformer by any manufacturer, doesn't necessarily have to be a Lionel transformer, it just has to be an AC transformer capable of generating 18 volts of AC power, you're going to need a power adapter cable. These cables are sold under part number 6-12893. And all they are is a cable with the Molex connector on the end, a 7.5 amp inline fuse, and 2 bare wires for you to connect to the terminals on that conventional transformer. The other device that we have here right now is the TMCC1 command base and cab 1. In just a few moments we'll show you how to hook up the Powermasters to a legacy system, what's required for that. We also have a 135 watt powerhouse and a 180 watt powerhouse. The 135 watt is a 6-12866 and the 180 watt is a 6-22983. The command set is sold as a pair under product number 6-12969. Okay, we're going to talk about how to connect your Powermaster to a conventional transformer. This conventional transformer can be a post-war ZW, post-war KW, RW, TW, basically any transformer capable of outputting 18 volts AC on the A and U, B and U, C and U, D and U terminals. The assembly is real simple. We take our power adapter cable and using the Molex connector, we plug it into the Molex terminal on the front of our Powermaster. We take the lead that has the inline fuse and we connect it to the hot terminal on the transformer. In this case, it's labeled track A. We take the wire without the fuse in it and we connect it to the common post or the U terminal for ground. That makes the connection between our transformer and our Powermaster. And the last step is to take the leads from your track. I've got these color coded, red for the center rail, black for the outside rail. Simply connect red to the terminal labeled A and the black or the outside rail to the terminal labeled U. The final step in wiring your Powermaster is to connect an additional wire from the U terminal that will ultimately run to the U post on your command base. We're going to remove the conventional transformer and put the 135 watt powerhouse in place of it. We unplug our Molex connector, take this out of the screen, bring in our 135 watt powerhouse. Using the Molex connector on the end of the cable, we're simply going to plug that into the front of the Powermaster. Now, when we power up the powerhouse, our Powermaster will have power. What we have here is a 135 watt powerhouse powering a Powermaster. The two terminals of the Powermaster, A and U, connected to the track. I have an additional wire from the U post of the Powermaster to the U post of my TMCC1 command base. The purpose for this single wire is to ensure that my command base is broadcasting the digital signal through the outside rails of the track. This way, when I run command-controlled locomotives, the signal is there for it to receive. I'd like to take a moment and go through how the Powermaster works when we set it into the conventional setting. What we have set up now is a conventional Polar Express locomotive and a Polar Express air whistle tender. So what I'm going to do right now is I'm going to turn the powerhouse on by turning on the power switch. You'll notice that the green light on the Powermaster comes on when it's receiving power. Powermaster is on. I'm putting 18 volts into the Powermaster. The green light is on. What I need to do first is I need to assign a track ID number to this Powermaster. Powermasters will accept only track ID numbers. So your choices are track 1 through track 9, effectively giving you the ability to run up to 9 Powermasters on your railroad. So the way we're going to program the ID number is we're going to take the program run switch and place it in the program position. Using our cab 1 remote, we're going to address track 1 and we're going to hit the set button down here. What I want you to notice is when I press the set button, the red light on the top of the Powermaster will flicker, acknowledging that it has received the command. Pressing set now. As long as that red light is flickering, it tells me that it's receiving the signal. That's all I have to do. I hit track 1 set. Now I want to move the program run switch back to the run position. On the conventional command switch, I'm going to leave it in the conventional mode so I can demonstrate how it operates. It's important to note that with a cab 1 remote, the cab 1 talks directly to the Powermaster, not to the command base and then to the Powermaster. Cab 1 at 26.75 megahertz talks directly to the Powermaster. So what I'm going to do is I'm going to press track 1 and I'm going to dial up the remote on the red thumb wheel. And as I dial up the remote, you can see the red light on the Powermaster flicker. The conventional locomotive is now in neutral. By pressing the direction button, I'm going to interrupt the power. When I let off, the engine will begin running in neutral, or in reverse rather. To slow down the speed, I simply turn the red knob counterclockwise. To change direction, I press direction. Track power is interrupted. Train comes up in neutral. Press direction again. Engine starts running in reverse. Direction again. I'm in neutral. Direction again. I'm running forward. With the Powermaster between my powerhouse and the track and set to the conventional mode, I'm now able to run conventional, non-command, non-legacy equipped locomotives wirelessly through my remote. So I want to get the locomotive running again. As the train's running and I see a collision coming, I can press the red panic button on the bottom of the remote. When I do this, track power will cease to be broadcast to the track. The Powermaster has shut the power off to the track. This doesn't cause any damage. I simply dial up the throttle again and the engine begins moving. Now, understanding that power has to be applied to the track in order for the air whistle to work, I want to go ahead and apply that power. I'll prove it's there by pressing the direction button 2 times. Engine ran, now I'm in neutral. Now I'm going to blow the whistle by simply pressing the whistle button on the remote. So what's happening is by pressing the whistle button on the remote, my Powermaster is sending my positive DC offset down the track to activate my air whistle. Now what I want to do is I want to show you how this works in command mode. So to turn the track power off, I'm going to press aux 1, the straight arrow key, and 0. Now I've shut power off to the track. I'm going to take my switch and move it to command. By having it in the command position, when I turn the Powermaster on, I'm simply applying 18 volts of power to the track, constant. This Polar Express locomotive is going to take off and start running wildly, on rollers of course. So we're going to press track 1, and we're going to hit the boost button. Okay, it's in neutral. Now what I've done is I've applied a straight 18 volts of power to the track. To shut that power off, I simply press aux 1 and 0. Do it again. I can also press the panic button. The panic button will shut the power off to the track. So by having the Powermaster between my powerhouse and my track, I am able to control my track power remotely using a cab 1 remote. Now we're going to wire in the legacy control system in tandem with the TMCC1 system and show you how that system works together with the Powermaster. Assuming you have a railroad with TMCC1 already installed and you bring the legacy system into the equation, you need to connect the Y cable from the legacy base to the TMCC1 base. But before we do that, it's also important to note that you need to take the single wire from the U post of the command base off of the TMCC1 base and move it to the legacy base. This is required because broadcasting a signal from both command bases will simply cancel each other out. So command-equipped locomotives will only run in conventional mode if there's a wire connected on both U-posts on the command base. Since the legacy base will become the primary base of the railroad, we need to connect the wire to the U-post on the Powermaster to the U-post on the legacy base. The next step is to use the Y cable that comes in the legacy set. We're going to use the end that says legacy base and plug it into the legacy base. Then using the other end of the cable that's labeled command base, we need to plug it into the TMCC1 base. Now what we have is a system that will work together. Any command sent from the legacy cab 2 to the legacy base will immediately be broadcast out this single line through the outside rails to that halo of the command signal. Any command sent from a cab 1 will go to the command base through the serial port into the legacy base and then broadcast to the trains through the U-post of the legacy base. It's important to note that just because we've added legacy to this equation does not mean that this cab does not communicate with the Powermaster. If you remember earlier, we mentioned the Powermasters receive a signal at 26.75 megahertz, the same frequency that the cab communicates with the base at. So even though we have legacy and a cab 1, only the cab 1 will communicate with the Powermaster. If on your railroad you decide to take TMCC1 out and only use legacy entirely to run the railroad, what you'll need to do, if you have Powermasters on your layout, is you'll need to purchase a Powermaster bridge. The bridge has a box similar to the command base and the Powermaster, but it says bridge across the front. It comes with a wall transformer similar to the command base. The command base is simply removed by taking out the serial connector and taking the command base and cab 1 out of the equation entirely. To replace the command base, we take the Powermaster bridge with the wall transformer plugged in and place it next to our command base. We take the serial port or the serial wire, computer wire that's labeled command base, and we plug it into our Powermaster bridge. Now what we've done is we've set up our railroad so that our legacy system is the primary operating system. Now, with the bridge in place, when we send commands from the cab 2 to the base at 2.4 gigahertz, a signal will come out of the Y cable, go into the Powermaster bridge, and the Powermaster bridge will broadcast at 26.75 megahertz to talk directly to the Powermasters. So now that we've got the command base removed and the Powermaster bridge installed, it's important to note that we recommend that the Powermaster bridge be a minimum of 2 meters away from the Powermaster. If the two are sitting side by side, the Powermaster will most likely not receive the radio signal being broadcast by the Powermaster bridge. So for the purpose of the video, we're going to move the Powermaster bridge over to this side, and we're going to move our Powerhouse and Powermaster to this side. Got roughly 4 feet between the two devices now. So because we've assigned the Powermaster as track 1 earlier, it's still retaining that address. So we're going to address track 1, and we're going to slowly begin to increase our throttle on a cab 1, or on cab 2 rather. As you can see, the locomotive begins moving. When I press the direction button, I'm going to interrupt power. Train goes into neutral. Pressing direction again, get the locomotive running in reverse. Increase the throttle a bit with the red thumb wheel. When I pull down on the whistle slider, the air whistle and the tender will blow. When I press the halt button, track power is shut off because the base, through the serial port, has told the bridge to send a command at 26.75 megahertz to the Powermaster addressing track 1. Now, halt is a global command. It affects locomotives, accessories, tracks, switches, everything. When you hit the red panic button, everything shuts down. So we'll do that again. We'll get the engine running. It's also possible to hit aux1 0 to shut off our track power. If your Powermaster is in the command position, it'll work the same way as it did with the cab 1. Effectively, your Powermaster bridge is functioning as a slave cab 1, doing everything that your cab 2 tells it to do when it comes to sending track addresses.